Hey guys, today we are going to continue working with graphing, and we are going to be graphing a quadratic function. Okay, so remember quadratic means it is something squared, and we are going to be graphing out of vertex form. And when we were doing our Desmos project, we wrote our equations for everything in vertex form, so we're just going to go back and review that again a little bit more and how to graph it without actually using Desmos, some simple strategies and parts of the graphs that we need to know. So first thing I want you to do is pause the video for just a second and match up the graphs that go along with each equation. So go ahead and stop the video and do that. Okay, so if you look, I just looked at the parts of the equation that we learned from our Desmos project on this first one here. This one here, I said was number 3 because I knew that it was reflected. It went to the left 2 and it went down 2. On letter B, I knew that was number 5 because it went to the right 2 and it was slightly narrower than a normal parabola. Letter C, I said was number 2 because it went to the right 2 and up 2. Letter D, I said was number 1. It was reflected and it was to the right 2. Letter E, I said was number 6 because it is reflected. It is to the left 2 and it is also up 2. And then letter F was number 4, which is to the right 2 and down 2, and the 0.5 made it a little bit wider. Okay, so here we have what is called vertex form, and the parts of the equation that we need to know are highlighted and colored in here, and we already should know what each of these things do. Okay, so we should know that that number out in front, okay, if A is greater than 1, that means that it is going to stretch it taller and skinnier. Okay, and if A is between 0 and 1, like a fraction or a decimal, that makes it shorter and wider. Okay, so that stretch for if it's greater than 1 is going to make it go super narrow, and the closer to 0 that A value gets, the more it'll flatten out. Okay, the H value, remember, H tells us left and right, and that tells us how many units left and right we are going to go. So if it is x minus 2 squared, for example, that means that we would move to the right 2, and if it was x minus 2, or excuse me, x plus 2 squared, that means we would move to the left 2. K is that value that tells us up and down. Okay, so whatever that is, if it was x squared plus 6, that means we would go up 6. If it's x squared minus whatever number 5, that means we would go down 5. Okay, and the other good thing is we can figure out where the vertex is. Remember, the vertex is that place where the parabola changes direction, right at the very bottom of your parabola. And that vertex is at H, the value of H, and the value of K. So when you want to find the ordered pair for the vertex, you're just going to look at those values there. Okay, some other important things to help with graphing in vertex form. We're also going to refer to the axis of symmetry quite often. The axis of symmetry from here on out I will call AOS, axis of symmetry, and it is basically when you have a parabola, it is symmetrical, which means here's your vertex. You have a line, a vertical line that goes right through the middle of the parabola, right through its vertex, and things on the right are the exact same as they are on the left. So if you folded it on that axis of symmetry, it would fold right on top of itself. And then we also have the y-intercepts. The y-intercept is your value of y when x equals 0. And you also have your x-intercepts, which we really are not going to use a whole lot with vertex form. We'll use that more when we get into standard form. But your x-intercepts are when a parabola goes down, turns around, and comes back up, the places where it crosses the x-axis. Where it crosses the x-axis is going to be your x-intercepts. So let's look here a little bit. Remember, we're not going to use Desmos. We are just going to use what we know, what we've learned in order to graph this. So first of all, we have our equation x plus 4 squared minus 5. So we know from what we've learned that we are going to move the graph to the left 4 and we are going to go down 5. So our vertex, okay, is at HK. Now keep in mind when we wrote that formula for our vertex form, it was x minus h squared. If you notice, we have an x plus 4 squared here, which technically, if you think about it, would be, if we're keeping the form, would be x minus negative 4 squared. So your h value is actually negative 4, which is where the going to the left comes from. So you're going to be at negative 4, negative 5. So you're going to have that parabola, that parent function that we've talked about, is going to move to the left 4 and down 5. So we're going to go 1, 2, 3, 4, 1, 2, 3, 4. Okay, so there's our vertex. Okay. The other thing is the axis of symmetry is that vertical line that goes through our through our vertex. And if we sketched a vertical line right through here, like this, okay, to write the equation of a vertical line, it is always x equals wherever it crosses that x-axis. And it's also, in this case with a parabola, going to be the x value of your vertex. So your axis of symmetry is that vertical line x equals negative 4 that goes right through the middle of your parabola. And then the next thing we need to do, so we have our vertex, we need to put a point on each side of our vertex so we have something to connect our parabola with. So our y-intercept, oops. So our y-intercept is going to be, remember, our value of y when x is 0. So to figure that out, all we have to do is go up to our original equation. We put 0 in for x, so we would have 0 plus 4 squared minus 5. Okay, 0 plus 4 is 4, 4 squared is 16, 16 minus 5 is 11. So our y-intercept, it's going to cross our y-axis at 0, 11. Okay, so I'm going to go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, and then I'm just going to reflect that point across my axis of symmetry. So my y-intercept is 4 units to the right of my axis of symmetry, so my point on the other side of it is going to be 1, 2, 3, 4 points on the, or 4 units to the left, and then we just connect our dots with a nice soft vertex down there. It's not a point. And we have our vertex, and we have a point on each side that we can use to connect. So let's look at a couple more of these. Okay, so we have g of x equals 1/3 times x minus 3 squared. And if it helps, you can always put that on the end. You can say plus 0 because there's nothing added on there. So if it helps you think about where your vertex is going to be. Remember, your vertex is at HK, and so we know from what we've already learned that we're moving to the right 3. Okay, so x minus h, my h value is 3. So it's going to be 3. My k value, I'm not going to move up or down, is 0. So my vertex is at 3, 0. Now, my axis of symmetry is a vertical line through that point. Vertical lines are always in the form x equals. Okay, so if I draw that vertical line in here, right through here, like that, I'm going through x equals 3, which is also the x value of our vertex. So that's x equals 3. And then we need to figure out our y-intercept. Remember, that is the value of y when x equals 0. So we're going to have our ordered pair 0 something. So we're going to put 0 in for x. So I'm going to have 0 minus 3 squared plus 0. I don't really need to say that. 0 minus 3 is negative 3. Negative 3 squared is negative 3 times negative 3, which is positive 9. So my y-intercept is at 0, 9, which is going to be right up here. And then I just reflect that point straight across my axis of symmetry. So this point is 3 units to the left of the axis of symmetry. I'm going to have one that is 1, 2, 3 units to the right of the axis of symmetry. And I'm going to sketch my graph. Again, it's going to be a nice soft corner down there, or a nice soft curve on the bottom. All right, last one here. I have x plus 2 squared plus 1. My vertex is going to be at HK, so we would have my vertex is going to be at -2, 1. So I'm going to put my vertex at -2, 1, which is right here. And then my axis of symmetry is just that vertical line that goes through my vertex at x equals -2. So that's my axis of symmetry, goes right like this, right down the middle here. Okay, and then I need to have my y-intercept. Okay, so my y-intercept, I'm going to put 0 in for x, so I'd have 0 plus 2 squared plus 1. 0 plus 2 is 2, 2 squared is 4, 4 plus 1 is 5. So my y-intercept is going to be at 0, 5. Okay, and then I'm just going to reflect that across my axis of symmetry. So right now I am 2 units to the right of the axis of symmetry. I'm going to go right across there and be 2 units to the left, and I'm going to sketch my graph like that, and I have my parabola. And next we're just going to have you try some of these on your own, so go ahead and good luck.